Stop listening. Okay, so now we got the part numbers for the roller engaging clutch and the solenoid. And we can look up their data sheets. Okay, so we're supposed to look up on the solenoid datasheet and see what its resistance should be, which would be a dead giveaway if it's broke without needing to even set up the 24-volt battery pack and test its continuity and its resistance with the multimeter. Okay, so yeah, we need to test the continuity and resistance of the solenoid, which is the yellow plugs. Can I unplug this? Oh my gosh. I pulled on it and nothing happened. What do you know? Ugh, what a mess. Is there some special way to remove stuff like this? Wake up. How to remove a connector from a PCB safely. Press return. Got it. That's really what I needed to see. So we need tweezers. I'm going to use surgical hemostats. Stop listening. I'm going to use surgical hemostats to remove this yellow connector. I have to do it left-handed because my right arm's hurt. You're not supposed to pull it out by the wires, and I figured that was the case. If you pull it out by the wires, you're bound to break it. Okay. Wow, it's a good thing I just bought a multimeter needle tip attachment, because I'm not going to be able to connect the leads into that thing to test it. I just bought a bunch of multimeter attachment tools. One of them I bought is this. It's a tweezer style tester for the multimeter. This actually plugs in. And the other one I bought is this needle small probe kit that will enable you to get into tiny areas, I guess. Oh, it poked me. Wow, that is small. That's sharp. I already stabbed myself. Okay, so that'll do it, man. That's just what we needed. Thank goodness I ordered that stuff. I thought I was being kind of ridiculous, but I've just been ordering everything lately, and it's kind of nice to see that something I ordered already paid off that fast. Alright, so I just unplugged my other cables. I'm plugging these in now. See if it works. Let's do a continuity test thing. It's working. Okay, great. This will definitely help us a lot. Alright. Continuity test for the solenoid. Let's do it. I'm just sticking it into the connector. It should beep. Okay, nothing happened. What the heck? Why isn't it beeping? I mean, that could mean it's broke, or it could mean I didn't make good contact. I don't trust myself right now. I'm gonna sit up so I can maybe get my right hand onto it more. Oh look, it's working. 91 ohms. 90 ohms. Heck yeah. We said it'd be about 80 ohms. Ha! You know what that means? I got it in there good finally. I didn't have it in well enough before. Let's try a continuity test now. I don't know why it's not beeping, but it's reading the right ohms. I don't know why it doesn't beep. I don't get that. It should beep, right? I don't know. Maybe not. Maybe because it's going through an inductor? I don't know. That's weird. I thought you could test an inductor with the continuity test, but it's not beeping, so go figure. I don't know. But it has the right resistance we wanted. Solenoid. Oh, no. It says 0.55 to 1.8 ohms for the solenoid. Whoa, that seems wrong. That's wrong. That's way off. We wanted 11 to 48 ohms for the magnetic clutch. The solenoid, that's nowhere near what we want. Let's pull out the clutch thing and just run our test for the heck of it. Remember, the clutch is the plug-in to the right of the solenoid. Okay, got that. Oh, let's run continuity test. 187 ohms of resistance. Okay, I don't feel like these tests are doing anything. They're not working. What the hell, man? I thought we could get some information that way. We're just going to have to test it by connecting a battery to it. That was a fail. They both... I know it's just a coil of wire, but it didn't beep for either one of them. I thought it would beep. Check it on the side where the wires go in. The wires are fully insulated the entire duration of being inside of this. Look. The ohm scale auto adjusts on a digital multimeter. Look at that. The insulation goes all the way in. There is no exposed copper on the wire at all. And it's the same thing on the yellow one. There's no way to get a reading unless we just shove it directly into... there, the pins. I don't think I broke them though. I think it'll be fine. You can't change the ohm scale on an automatic digital multimeter. It changes itself. Auto adjusting. That's for analog multimeters. This is a digital one, a good one. Alright, well, let me get my batteries out then. Let's do our next stuff. So, the results of those tests were useless because both of them failed, and that just can't be right. So, whatever. Next thing I wanted to do is attempt to actuate the solenoid to see if it is working at all. I need to get my lead acid battery pack that I use for kayaking. Okay, so red would go to black. To wire these in series, let's pretend this is the back battery. Okay, red. Wait. Gosh. I think red goes to black. And then black goes to red. I think. Nope. Maybe not. No, it's gotta be that, right? Okay, guys, stop listening. There's my in-series drawing made on the fly. Got battery 1 on the right, battery 2 on the left. Plus goes to minus, and then plus goes to plus of the top 24 volts. And the minus from battery 1 goes to the minus of the 24 volts. The two individual batteries are 12 volts, but wired in series they form 24 volts. I don't know why I saw smoke, but maybe I messed it up, so I'm just gonna like back up a little bit and make sure I do it right. So we'll define battery 2 as this one on the bottom. Okay? No, battery 1 is the one on the bottom. Okay. So we're going to connect its minus to the minus. Wait. Okay, it's minus to nothing. Oh, no wonder we screwed up. Okay. Its minus goes to nothing. Now, battery 2's plus goes to the minus. Battery 1's plus goes to the minus of battery 2. Okay. Battery 1's plus goes to the minus of battery 2. Got it. And then battery 2's plus is our plus. Battery 1's minus is our minus. Got it. So these should be... Wait. No. What? Battery 1's minus is our minus. Okay. Battery 1's plus goes to the minus of battery 2. Yeah, this is correct. Okay. Let's test it with our multimeter, I guess. Yeah, let's test it with the multimeter then. Where is my multimeter? Here it is. Turn to voltage. Okay. Let's connect this to here and this to here. $11.14 volts. That's not at all what I expected. What? Oh. Wait. No, I'm doing this right. No, I'm not. I'm not doing this right. Plus to minus. Minus will be our minus. We need one coming off that positive terminal. How do I do that? We're gonna make a wire that joins up to that thing. Okay. Sorry I'm not talking that much. So I'm going to strip this wire on both ends. I'm going to apply maybe a spade connector. And then clamp it down to the red part of our battery 2. And then that will be our ending point of our series connection. I did the series wrong before, but I figured it out. I just didn't I didn't visualize it thoroughly. I was just kind of rushing. It's not that hard, but for some reason I was blanking out, I guess, on the principles of wiring batteries in series. Okay. Probably gonna want these. Yeah, these will work. Red alligator clamp is what we want right now. Okay. No, wrong one. Let me get this one. Oh, you a-hole. Oh my gosh. Okay. Alright. Stop listening. Yeah, baby. 23 volts, baby. I did it in series right now. I knew I did, but gotta always test. Okay. So now we need a way to actually stick this into those things. Maybe jumper wire? Jumper wire might work. Let me see. I don't even know if it'll go in. Let me just get a... Okay. What the hell? It worked. It went right through the connector with the jumper pin. Let me show you. And you see it went right through. Yellow connector. Oddly, it went all the way through and it came out the back side of it. You can see the pin went right through all the way. So that was weird. I didn't think that would happen. I didn't force it through either. It was just a hole that went all the way through. That was just unexpected. Anywho, we just need a black jumper now. And then we can connect to that. Okay. Okay. I'm gonna use my quick connector thing. These are really fast connection fittings. Okay. Alright, so that connection's done. And then for the black, we have an alligator clip, so that'll be easy. But before I connect them, I want to get in position to see it actuate. Presuming it actually even actuates. That's the whole point of this test. My theory is that it will not actuate at all. I'm hoping it doesn't actuate, because then we've narrowed down what part's broken. Alright, so this thing is going to move if it actuates. If it actuates, that metal thing is going to pull out. It'll move. It'll move this way toward us, toward the camera. So let's test it. Holy crap, it's moving! It's moving! I mean, that's not good news in a way, but it's also damn cool that I just made something move. I feel like I'm not crazy. Something actually worked. Makes me feel like I know what I'm doing. Now the next question is it moving far enough? It is moving enough. I did one full rotation, watch. Alright, it's clamped. Wait. Yeah, see, I can move it. I can move the pickup roller now. And then I'll take it off, and now I can't move the pickup roller. So it's working. Yeah, this printer, all the motors on it are 24-volt motors. That worked. I guess we just exonerated the darn thing, didn't we? So it's got to be this clutch then? Let's get it out of the wire harness completely and run tests on it. Stop listening. Alright. We just verified the freaking solenoid works. That's incredible. If the solenoid's still bad, it could be that the DC controller board isn't sending out the 24-volt signal to the solenoid. Maybe the pins that send that out got somehow compromised. I just assumed the solenoid was bad. But like I said, it could equally be the magnetic clutch that's bad, so we could still find a bad part. But if it's not this, then we truly know that either the gears were hung up and I already fixed that and the printer would work as is right now, or the DC controller board's not sending out the signal properly. Either way, we have workarounds for everything already in our troubleshooting guide. I have everything figured out. This printer repair cannot fail. the printer might be sending power to the solenoid, but just not be starting up the magnetic clutch, so that even when the solenoid has had power sent to it and the pickup roller could technically start turning, the magnetic clutch is not activating, and so the rotational gear turning here is not translating to the internal shaft, because this clutch causes the shaft to become coupled to the gears. And so if the shaft doesn't turn, then the pickup roller doesn't turn, and that's why it's not picking up paper. So it could be this part, which we need to test next. If it turns out this part's working, then it's not sending power to either this clutch or the solenoid. And then we could either try to backtrace that or just start getting into some total workarounds involving microcontrollers, which is something I'm leaning toward, because I don't really think I can do board level repair on this PCB. Well, I guess I could, but then aren't we getting into logical analyzers and stuff? I don't know. I mean, I'd have to find a bad trace or something? I'm not sure what I'd do with then. I guess I could analyze the board. I never thought to really do that up until now, but if both parts are exonerated, then maybe some careful analysis of the board would be in order. Maybe we'll see an actual damaged section of the board, which would be weird, because the board's completely protected. Why would that happen? No water got on it. Could be a blown capacitor. That seems to be a common failure point on a lot of electronics. I think it's really cool that I got to see that solenoid actually work. That was really neat. It shocked me just seeing something move. I just feel like everything I've done has just not worked. I don't know. It's just rare that something happens that you're expecting to happen. Like, you guys saw me do the continuity test. I heard no beep. You saw me do the resistance test. I got resistances that were not expected. Like, everything's been not working right. Although maybe I just wasn't connected up to the pins correctly before. Let me try to run those tests just out of curiosity again. Except now that we got jumper wires in there, we're going to get good continuity here. Alright. Should beep. No, it does not beep. You would think a solenoid would beep because it's just a coil of wire, but it does not beep. 100% does not beep. And in fact, $95 ohms, it still says. So we did have good contact. And the ohms was not what we expected it to be. It was supposed to be like, what was it supposed to be? For the solenoid, we had written down that it was supposed to be 0.5 to 1.8 ohms, give or take, is the solenoid's internal resistance. It's 95 ohms. That was not expected at all. And the continuity test utterly fails. There's no beep. So, all those types of tests I came up with were not successful. But thankfully, the 24 volts applied across its leads was a successful test. So that's nice. Alright, I'm connecting red to red of my 24 volt supply. And now I'm connecting the black. This is designed to stay on. Oh, I felt it. I felt it move. Holy crap. There, coupled as hell. I can't even stop it with my fingers. That's working! What the heck? That's fully working, man. What the hell? Both parts are working. That is working, man. 100%. That clutch is working. You feel it click. I mean, it's locked in. So, what the hell? The clutch works. The solenoid works. And if they worked, then everything should work. But they don't work usually. I mean, the pickup roller doesn't work, does it? So they must not be getting the 24 volts at the right times. They must not be getting the 24 volts at all. This was not expected at all. I figured one of these two parts had to be failing, and neither one failed. What the heck do I do now? I gotta go to extreme lengths now. We gotta begin the next phase of troubleshooting. What happened to the printer before it stopped working? I was putting some food in my mini fridge with my one working hand that doesn't have a bad shoulder, which is my left hand, and I kind of over-leaned forward, losing my balance, and I couldn't move my feet forward to catch myself because my chair was in the way, so I was just going to fall on my face unless if I put an arm out, and I couldn't put my bad arm out, and the left arm was already holding food, so I was forced just to kind of fall onto my knee, and my knee was right above my printer tray 1 paper pickup carriage door, and the knee slammed down on that, shattering everything to do with the paper pickup door. And from that point forward, I got like one print to work, and then it just stopped working, and it no longer would pick up paper. So the printer would do everything. Stop listening. The printer would do everything indicating it's working except pick up paper. And I was able to verify everything's working by manually feeding in the paper at the right moment, and it prints fine. So I was able to determine that the paper pickup is not working. And I was able to take apart the printer and detect that paper pickup involves two components. One is a magnetic clutch that couples these gears to the center shaft, which turns a shaft, which turns gears, which turns the paper pickup roller itself, which is a rubberized D-shaped wheel that turns, scooping up a single paper. It turns toward the front of the printer, and it grips a paper and feeds it into the machine. The other component is a solenoid with a lever latching mechanism that serves as a brake for the pickup roller, preventing it from rolling by accident when it's not supposed to be. So those two components are involved. I tested both components today, and both components worked. So now we know that one of the two components is just not getting power, because the gears were tested to be working because I could manually feed the pickup roller by turning the shaft myself. So one of these is not getting power from the main brain's DC controller printed circuit board. Now we can look at that board, I guess, to see what's wrong. We could also test the signals reaching both of these components on a test print to see which component isn't getting 24 volt sent to it with the multimeter. So I guess my next step would be to reassemble the printer, everything included except for the panel that covers all this stuff, so that I can still access and probe with the multimeter while the machine's plugged in during a print job and see what's actually happening, which will be really neat. So that's pretty much the next step in this process. I haven't checked. I haven't looked at that board. I automatically assumed it'd be one of these two components. I didn't think the board was the problem. So that'd be worth checking into. That's a good idea. The connectors would not have been loosened, I don't think. The fall wouldn't have impacted that. Have you tried opening gates? What do you mean? I don't know what that means. Maybe a limit switch that detects paper in the tray is out of position. No, I already ruled that out. There's a switch that detects paper in the tray. And if that switch is not deployed, the thing says no paper, load paper. I taped down that switch and then it says ready to print. So that's not even relevant. All that determines is whether or not the printer requests paper or thinks everything's good and it just begins the print job. And I've already been able to get successful prints with that switch taped down. So that's just one thing I ruled out right away. I'm plugging back in the two components to the board. Nice. All right. There are two transistors right near my switches. I imagine one of those could have failed. That's certainly a possibility. And I'm assuming since the transistors are right near my switches, they could be likely culprits. Check it out. So, oh, I need to put the camera in that area. Okay. So, these two yellow cords here, right here, go to the solenoid, and these two green ones right here go to the magnetic clutch. And I'm looking right here, and there's two transistors here. Boom, boom. And one of those transistors, if they failed and wouldn't switch on anymore, then one of these components wouldn't turn on. And that could be it. So I could replace both those transistors at some point. I didn't see any type of like capacitors bulging or colored wrong. Everything looked fine with all the capacitors. I don't see any burn marks or anything. It's not even that big of a board. Yeah. So I think it might be one of these two transistors here, since the two switches are right there. I imagine those go to those. Yeah, so that's something we could look into, but the next step is going to be for sure to actually run volt tests on those connectors with the printer running. At the moment they're supposed to switch on, I'll see if the voltage pops up. I'll also see if they physically work. I mean, maybe it's all working now. Maybe the gears were just jammed a little bit, and after I took it apart and manually turned it, maybe I unjammed them, and the 24 volt motors just weren't strong enough to turn through the jam. And now that I freed up the jam manually, it's all just going to be working. And that's a real possibility. So that's even worth running the test of putting it together and running a test print again. Now that I've manually turned the gears, I might have unjammed it. Yeah, checking the gate drain from the source. Well, I wouldn't test the MOSFET. I would just put it directly on the leads leading out to the components that are required to be working for this process to work, the pickup process. So I'll just connect jumpers to those leads and verify that they're getting voltage at the appropriate times while the printer's actually running a print. So that's my next step. I already tried looking up the resistances, but that's irrelevant now because I tried both of the components and they both worked with an actual 24 volt power feed, which is what they require, 24 volts. The expected resistances I tested for were way off, but those were based on similar components that had data sheets. These do not have data sheets. These are proprietary, I guess, HP things, or I don't know. There were no data sheets for these components online that had internal resistances marked. So I got some resistances I was not expecting, but whatever. Alright, I'm going to fully regroup then. And put everything away. Form my new plan, and then methodically take that on. I like to make detailed to-do lists rather than work on the fly. It just makes it more brainless, freeing up my mind to think about other things and concentrate on what I'm doing. We're learning so much, so regardless, this is an awesome experience. I'm thrilled. And I will fix this printer, that's not even a question. Don't worry about that. I don't take failure for an answer. I don't quit. I'm like a pit bull. I'll keep fighting to the death. Wake up. Note that I tested with 24 volts both the solenoid and the magnetic clutch, both the solenoid, and found both to be working. Press semicolon. Press return. So that leaves them not getting 24 volts from the DC main brain's controller board PCB. So I am planning to test it now. Press return. With a print job, while measuring the voltage leading out to the parts with jumper wires and a multimeter. Press return. Press semicolon. So I will reassemble the printer except for the door that covers these areas. Press semicolon. Move. Moving. Press E. My battery pack back out to hallway for now. Press return. Fully reassemble the printer in reverse order of how we took it apart, except leaving off the door that covers the gear assembly and printed circuit boards. And run long jumper wires off the main brain's printed circuit board to test the voltages coming to each of the two critical components, the magnetic clutch and the solenoid, so that we can see which one is failing in real time, both through testing the voltages and through visibly watching them fail. Press semicolon. Note that there is a possibility the gears were just jammed up and manually turning them freed them up and everything will just work now, period. This is actually a great place to stop. Stop listening. Alright guys, so the next time we work on this, which most likely will be tomorrow, yeah, I believe we'll be able to tomorrow. We're going to start putting it all back together, and then we're going to plug it in and try to print. And the hope is that we'll be able to do more testing with actually watching the things fail. We'll be able to see, hey, that solenoid didn't move. Or we'll be able to see, hey, that solenoid did move, but the magnetic clutch is not being actuated. And then we can go about searching for the faulty transistor on the printed circuit board, or possibly creating a Arduino-based workaround to get power to where it needs to be at the appropriate times, and also detect from other pins that Arduino can read in when power goes to one thing, and then based on proper timing have the Arduino tell the other thing, hey, turn on. And so he can act as a middleman, as a workaround for the printed circuit board that's the main brains of this thing, not sending power to certain pins when it's supposed to be. So that's a fix that I can always turn to as a last resort, which will be really fun. So yeah, man, we're getting so close every time, man. We're just moving closer and closer. It's really exciting stuff. So anyways, guys, peace out.